Howdy again, it's Mr. Pete, your YouTube shop teacher, and this is tips number 1006. In the previous video I talked about this ATLAS armature mica undercutter, and it's going to take several videos to cover this. So the restoration of the device, and then I want to show how to use it to actually undercut the mica on an armature. But this was damaged in shipping, as I said before, and there's several other things that I need to do it, include wiring and so on. So it'll take two videos just to show you that. And here's another picture of it, the original ATLAS repair sheet. So let's start. So what I'd like to do in this video is to take the motor off and rewire it, because you can see that the switch is bad, or the wire is bad and cracked. It's 60 or 70 years old, so there's the new wire. And as I said, I'm not going to put the switch in it at this time. And then I also want to machine a new arbor. As you remember, this one is bent, probably in shipping, but maybe it happened 50 years ago. So those are the two things that I'll be doing in this video. And then the following one, I'll take the rest of it apart and put on the replacement crank and clean it up, and probably not paint it because the paint does not look too bad. I love that color, but it'll get cleaned up real good. So hang on to your hat. Here we go. Okay, the motor was held on by 4 screws. I'll remove the last of them. And out it comes. I think I'll just cut the wire off because it's so badly damaged. But again, a big thanks to Jimmy Goff over in Indiana for donating this for the good of the cause. So this is a Bodine motor, and it runs fine, although the bearings seem just a little stiff. And from the looks of these flanges, I thought they were ball bearings, but no, they are brass bearings, as you can see from right here. And I have oiled it, and I'll work it a little bit more. I think it'll be okay. But as I had shown you before, maybe you didn't see that video, the wire is just terrible because it's so old. See how it cracks? So it doesn't meet electrical code anymore, needless to say. And it's a 2-wire ungrounded system, so the new cord will meet all of your standards. Look at that ground. Well, you know what? My original game plan here was to open the motor, take the end bells off, and do the wiring on the inside of the motor. But you know, that's a nightmare. You know there won't be any room in there. It'll just, matter of fact, I couldn't sleep last night thinking about it. But now that I've taken off that 50-year-old sticky tape, I realize that the connection for the cord is made externally, and there are connectors there which I've cleaned up with brake fluid. So I'm going to take these connectors off if I can, and solder the new wire on. And I know you Sparkies out there are having a fit about this, but the third wire, the ground wire, the earth, will be run simply to one of these screws here with a connector. And that will ground it, but I'm sure it's against the code. Matter of fact, don't make a comment, because I'll just feel bad if you do. I'll be back in a few minutes. While you were nodding, nearly napping, I painted the motor. Doesn't it look great? Just kidding. You know I wouldn't go to that effort. So I shined it up and cleaned it real well. And you know, of all things, I tried white gas, and that took the grime off, but it made it dull. So of all things, I found a new use for WD-40. I really shined it up, and it's good enough for what it was. Unfortunately, my wife put that label on there with Jimmy Goff's name on it, and it took the paint off. But does it matter? No. And then one other thing that I wanted to tell you about the shaft here is, you might recall that the arbor is bent, and in the previous video I said I hope that the motor shaft isn't bent, that it would be the arbor rather than the shaft, and I was correct, or I lucked out, or whatever. But this would be the weak point here, because it's thinner than this shaft, so guess what's going to bend? Alright, now on to the hard part, which is taking these off and soldering, or I'm not sure what I'll do, but I'll get back to you, and then I'm going to put shrink tubing on it. You know, sometimes it's a hardship having too much. So I got two full drawers here of electrical connectors of every size and description known to mankind, and that's not even the mother load. The mother load's out in the cold garage. And similarly, just how much shrink tubing do you need? 50 feet in there, hundreds of pieces, and a whole bag here. And I know, it's actually a burden, but the thing is, I got everything I need without going down to Ace Hardware store, and I paid pennies on the dollars. For instance, this package was 91 cents. You can't even buy a candy bar for that now. And I'm serious when I say it took me over 20 minutes to go through all this stuff. But look, I got hundreds of the connectors here that are just the right size. And then even with these that I just showed you, I guess, I have those in two sizes, and a whole box just a little bit bigger so that I could really get just the exact size that I needed. And you know, I waste so much time telling you about this and even doing a rehearsal where I was wondering if the red, which looks way too big, would shrink down, and it's going to be perfect. So I got everything I need. Okay, here's the general plan now, and many will say, well, you need to solder that. Sometimes it's very difficult to solder old wires that are 60 or 70 years, even though they look semi-shiny when you strip the insulation back. And one other thing here is that the wires coming out of the Bodine motor are the older style that's like fabric, and it's in quite good condition compared to that fake rubber or plastic, whatever it is. And again, the game plan here, there's my ground that will go to this screw, and I've already got the connectors crimped on to those leads, and then I can slide the foreskin, I mean the shrink tubing, back over those connections, and then ultimately I have in place here larger shrink tube, if this works, to go over the entire assembly. And I'm sure I'm still doing something that people don't like, but that's, and this cord, you know, this is from a computer, but you know, this motor only draws 0.8 amps, so that's almost nothing. You know, you could run that through a human hair. Well, not quite. Okay, that was quite tedious, but the shrink tubing is on there, and there's the ground, which I will tighten down, and then slide the other tubing up and over, right about there, and a little heat, and it'll be done. And then, as always, a man with suspenders and a belt, wearing both suspenders and a belt, has his spare, but he won't need it. Okay, there it is, and it took over an hour. That's why I didn't film much of it. And you're right, I don't have a switch, but let's see if the darn thing works. That's really the acid test, isn't it? And will I get a shock? It is grounded now, you know. Too good to be true. Now that the wiring is done, I will turn my attention to the bent arbor. And even here you can see how bent it is. But anyway, I decided to redesign this because I'm far smarter than the Atlas engineers, you know. But the reason I'm going to redesign it, this is kind of a difficult transition to make on the lathe and have it look good. And this is the weak point. I've already determined that. So I have decided to modify the, this is the one off of the True Arc lathe, and I showed you that in the last one. So this isn't quite as delicate because it's only small in diameter right near the end. Now I can't use this one because it does not have a motor shaft hole. So this is essentially what I'm going to make. And I took the liberty of making a prototype out of Delrin, no hole yet. And of course there's a tiny hole in the end for a 540 left-hand thread. So it'll look exactly like this, only made out of steel. 5/8 diameter, and then turned down to 3/16 on the end. which is pretty small, but it has to be able to reach onto the commutator without touching the commutator. So that's what it's all about. You know, it's very difficult to measure a taper in terms of degrees, and I'm not sure how you do it, but I fiddled around with all my different protractors and everything, and finally I made a setup on the lathe, and I'm going to turn the taper using the compound rest method on the closing lathe, and I did determine that it's a 4 degree per side, or 8 degree included angle taper. So let's step over to that beautiful closing lathe and see how badly I can mangle this. Okay, I'm at the lathe now, obviously, and I've set it for 4 degrees, and boy, when you're 81 years old, you need a lot of light and a lot of magnification. And by the way, I just bought a brand new one of these, and I put the collet attachment on. That's 5/8 material, and I will be feeding with this, locking the carriage, and basically just taking it to the line. I thought I'd show this view first so you can see what my hands are actually doing. Okay, the taper is done. I'm down to the correct diameter at the small end, and now with the tiny center drill I will mark it, and then this is a number 38 tap drill and a 540 tap. And now a 540 right hand tap. I need a left hand. I do not have one, so I'm going ahead and threading it this size. If it fails and it slips, I will remake this if I can get a hold of the correct left hand tap. And I'm going in about a 1/2 inch deep, guiding it with the tailstock center. Some of you younger guys may not even be familiar with the size 5 or 540, but a 5 is exactly 1/8 of an inch. But you don't find 5s being used much anymore, and this is an old item. But if we got an 1/8 of an inch hole in the cutter, we need an 1/8 inch screw, and there's a little right hand. I wish it was a left hand. Well, I got the left hand screws. I don't have the left hand tap, and then that'll go. And does everyone out there understand why they are using a left hand thread? Okay, now I will take it out of the collet and saw it off. Then I have to return and drill and ream a 5/16 hole in the other end. Now I'm going to cut it off here so that it's the same length as the original, not the length of the true cut. The arbor is cut off, faced, and reversed in the collet, and now off camera, center drill, one size under 5/16, and this is a 5/16 reamer. 5/16 is the diameter of the motor shaft. Okay, there it is. Only one more thing to do, and I'm comparing the one that I just made with the 2 others, and that is to drill a tiny little hole here and tap it 832, which is the size that they used in the original. Now, if anyone out there is wondering why the diameter here is, the OD is 5/8, it looks kind of big, but we needed that thickness. By the way, here's my new Mitutoyo calipers, but we need that thickness for the thread on the set screw. Now I'm not going to show that, but I think I will use the jig to drill that because I like a nice centered hole. Don't you? I don't think I mentioned it, but the hole is exactly 1 inch deep. Not that it matters because you will never make one of these, but I have the hole drilled and tapped and a set screw in it. and it's going to fit right onto the shaft. Now, looking at the parts list, there should be a washer here. I can't tell if that's a washer or not, or if it was lost somewhere 70 years ago. Anyway, this will go on. Oh, I got to back the set screw off a little bit, and the set screw will bind against the flat on the Bodine motor. When you drill and ream a hole on a lathe, there's always the possibility of it not running true later on due to the drills deflecting and just the tiniest little details like that. So I made a setup here just to see how true this actually runs. So the motor's in a vise, so it can't move, and I'll move the camera in because I know you can't see that. I'm pretty well zeroed here, won't you agree? Wow, you know, it's pretty much within about 1,000th, 1.5 thousandths or so. So I am incredibly encouraged and satisfied and happy for that matter. I should have done this a long time ago, but this is the original bent one, and just to show you how badly it was bent, let me do the same thing here. And you can see it's what, 40 thousandths off? You can see it wobble as well. And that's why I had to make a new one. This is what is known as a universal motor, so that means it has brushes. And I just now noticed that here's the brush on one side, and it's under that protective Bakelite or plastic, whatever it is. But I noticed that's missing on this side. But that does not seem to affect the running in any way. Can a fella get a shock off of that? I wonder. In summary, there's the bent arbor, the prototype, the finished one, and the true cut inspiration. Well, I know there's about 1,500 people out there that are mad at me for not installing a switch, but you know what? It runs just fine. By magic. I can just think it on, so I don't really need a switch. Just kidding, the magic was my foot switch off the Unimat. Well, that concludes tips number 1006. And in review, I rewired the motor and cleaned it up, and it runs great, ready to use. And I machined a new arbor that seems to work quite nicely. And in the next video, which will be 1007, I will finish the rest of the unit, put on a new crank, clean it up, and so on, tune it up, and then also clean up these two chucks, which are a little bit rusty, but just need a little bit of touch-up. Hope you enjoyed the video, and be sure and leave a comment, and I'll see you in the next one.